All right, moving on. We're up to hyperbola. So the hyperbola was the one that looked kind of like two bits of a conic section. Its formula is very similar to the ellipse formula. Always has to be equal to 1, but this time it's a minus. All right, so that minus indicates a hyperbola. Okay, so what does that tell us? It tells us that it's actually called a rectangular hyperbola, and that's because there's a very special rectangle in it. So we've got B's and A's here around our centre. We haven't moved it at all yet. So when we have got B's and A's, we're looking at this point as being B, this point as being A. All right, that forms a rectangle, and that rectangle helps us draw it. So we need that rectangle to help us to find out that A, in this case, is our intercept. So we're going to go through those 2 points, all right? But we've got asymptotes. Remember what asymptotes are? Right, they're lines that our graph goes towards but never touches. So the asymptotes are through the corners of this rectangle. So those are our asymptotes. So when we draw our graph needs to look like this. All right? How could we get it in this bit? What do you think would have to happen? Yeah. So we just flip these two round. The y would be here minus the x. And then it would be drawn this way with our b's being our intercepts. Okay? Right. Okay, so what have we got here? We've got 2 other really important points. And again, C and negative C are foci. So they're very important points because they hold a relationship between every other point on this line and C and A. So again, it's Pythagorasly related. This time, though, it's B squared equals C squared minus A squared. Or it's C squared equals A squared plus B squared. All right? So that's the relationship needed between any point on here and C. It builds up a right-angled triangle. So the asymptotes have equations too. They are gradients of plus and minus B over A. All right? Plus and minus B over A. So if we had it as an equation, it would be y equals plus and minus b over ax would be the equation of the asymptotes. Right, they go through the centre, so we don't have to worry about moving them. Then, of course, this graph can change from the centre. So our general equation would be this one. Okay, so the centre's now moved to PQ. Now again, we can do all of the things related to completing the square to find the formula and rearranging it, etc., etc. So those skills still haven't gone anywhere. But one of the things that comes in here is eccentricity. So depending on the relationship, we can get skinny ones or fat ones. All right, if we've got skinny ones, here, eccentricity. E equals C over A. So if we started at 1, where the hyperbola is going to go from being a skinny one towards a fat one. All right, so as it increases, it goes fatter. Okay, right, we're going to leave it at there. We're actually going to cover parametrics for these ones today too, because really they're not much different from circles and from ellipses. So the parametric equations for hyperbolas are slightly different, but they work in exactly the same way, in that they this time are sec for x and tan for y. But everything else about them is the same. You can go between this and this equation just by operating it. You can have your plus p plus q on the end for your centre. It works in exactly the same way.